All right, so we're looking at 10.1 and 10.2, solving equations. All right. So an equation is a statement that two algebraic statements are equal. So an example of that is x plus 5 equal to 7. All right. So whenever you're talking about solving an equation, you want to know when is the statement true. In other words, when is x plus 5 equal to 7? All right. So we're going to be solving to try to find the solution. Your solution will be value or values that will make an equation true. It is possible to have more than one solution depending on the complexity of the equation. The ones you guys will be dealing with in these sections will only have one solution. Generally only have one solution. So you want to know what is the value that will make this statement true. When you look at x plus 5 equal to 7 and the example here for the solution for this one, if I can get my eraser to work, it's x equal to 2. I'm going to make that purple as well. All right. You can always check your solution by plugging it back into your original equation. So if I take this 2, plug it back in right here, if it does not create my true statement, then somewhere I went wrong in my calculations. So to answer the question, when is that statement true? When is x plus 5 equal to 7? That's when x is equal to 2. All right. So we will solve by what I call opposite operations. In other words, there are operations that undo what the other one does or what the other one do. Undoes what the other one do. Undoes what the other one. Anyway, so addition and subtraction will undo each other. Multiplication and division will undo what the other one does. So going back to x plus 5 equal to 7. My goal is to get x by itself. I want to have x equal to whatever that number is or whatever that solution is. So I have to undo what's being done to x. 5 is being added to x. So to undo that, I will subtract 5. Now your equation is split up into two sides, left side and right side of your equal sign. And whatever you do to one side of your equal sign, you have to do to the other side in order to keep your equivalency. So if I decide in order to solve out to subtract 5 from the left side of my equal sign, that means I also need to subtract 5 from the right side of my equal sign, once again, in order to keep my equivalency. After that's done, 5 and negative 5 will cancel. Then 7 minus 5 is 2. And that's how I'll get my solution. And so that is the foundation of solving your equations. Your goal is to get x by itself. And the way you go about doing that is by performing the opposite operations that are being applied to the variable that you're trying to solve for. All right. Any questions? Just trying to erase this stuff so we can walk through it.
I have one question.
Mm-hmm.
So, I remember you saying that in order to check it, you had to do something. I forgot what you said. We had like how to do it.
Okay.
Um, will we have to do that on the test as far as like show you like to show you if it's right?
No, that's up to you as far as doing the check on that.
Okay.
But the way you can do it is by taking your solution and plugging it back into the original equation where you see that variable.
Oh, yeah. Got it. Duh. Thank you.
It's all good. All right. So now just doing a few more one-step equations before we go to add a little more to it. Y minus 10 equal to 15. If I want to solve for y, I would just add 10 to both sides. Remember your equal sign, you know, is what dictates what your sides are. And then so positive 10 cancels on the left, and on the right, you have 25. So y is equal to 25. Well, let me do that. All right, so the next one, we have 5a equal to 13. So that's 5 times a. So in order to solve for 5, I need to divide, not to solve for 5, but solve for a. I need to divide by 5. 5's cancel. A is equal to 13 over 5. I'm going to keep my red. All right. And then one more like this. We have x divided by 9 equal to 11 over here. So it's x divided by 9. So that means I need to multiply both sides by 9. 9 over 9 will cancel. X is equal to 99. All right. So going back to this one, 13 over 5. Notice I didn't convert that to a decimal or to a mixed number. You do not have to. Um, that number or that solution is good enough. Now, if you have to reduce it, you are expected to reduce, and they're not going to tell you to. They just expect you to reduce it. So just making sure we're not confusing with converting to a decimal, converting to a mixed number, and reducing. So sometimes people get those confused. So 4 over 6, and this process down here, this is reducing, and this is what they will expect you to do and hold you to doing. In other words, I have 4 over 6. 4 can be broken up into 2 times 2. 6 is 2 times 3. I have 2's that are in common, so they can cancel, and that leaves me with 2 over 3 as my final answer. So that's reducing a fraction. Converting to a decimal is not considered reducing a fraction. Neither is converting it to a mixed number. Those two things you do not have to do unless they specifically say something like that, but that's not normal. We just talking about solving your equations. Leaving it as 13 over 5 is good enough. All right. Questions before I scroll up? All right, hold on 1 second. I want to check something in 103. No, not 103, 101. Yep, got that. That's all right. We'll do a few more, then we'll come back here. All right. All right. So let me erase some of this so we can walk through it. All right. So if I have x plus 1/3 equal to 3/4, and I want to solve for x. So it's the same thing that we did previously, just that this time we have fractions involved. So we would subtract 1/3 from both sides. The 1/3 will cancel on the left. And then on the right, we have 3/4 minus 1/3. Don't forget, whenever subtracting or adding fractions, have to find your common denominator. All right. So LCD is 12. So we multiply top and bottom by 3 for that 3/4. That turns into 9/12. That negative 1/3 turns into 4/12. Negative 4/12. We multiply top and bottom by 4. And then 9 minus 4 is going to be 5/12. All right. Questions? Any questions? All right. All right. So naturalize here. Let me block this out. Let's look at 2x plus 1 equal to 5. So your goal is to get x by itself. You want to solve for x. So you want to undo what's being done to x. The most efficient move is to move the 1 first. Now, if you wanted to move the 2, you could, but you have to divide each term by 2, which would create fractions where you may not want to deal with fractions. So the most efficient move is to subtract 1 from each side of your equation first. 1's cancel on the left. That leaves you with 2x equal to 4. Divide by 2. X is equal to 2. All right. Very similar situation when we look at 6p minus 1 equal to 17. I should have put something else there. Well, I got it now. So first thing we would do is add the 1. 1's cancel on the left. Leave you with 6p equal to 18. Divide by 6. P equal to 3. All right. Before we go to another one, questions on those two? All right, we good to go. Let's see what we got here. That's what we just did. All right, let me erase some of this stuff. All right, so let's look at this problem. We have 6x minus 4 equal to 2x minus 8. So this time, notice we have x in two different places. So our goal should be to get all of our terms with x to one side, all of our terms without x to the other. So we have four different terms here. We have 6x, negative 4, 2x, and negative 8. So it doesn't matter which one we decide to move first. As long as you do everything correctly, eventually you come up with the same answer. So let's look at subtracting 2x from both sides. I'm moving the whole 2x to the left side, so I'm subtracting 2x from both sides. That'll give me 4x minus 4 equal to negative 8. Then I will add 4, because remember your goal is to get all of your terms with x on one side, all of the terms without x to the other. So now I'm taking the 4 to the other side, but I have to do that by adding it. So that would be 4x equal to negative 4. And then to finish it off, divide both sides by 4. 4's cancel. X is equal to negative 1. All right, questions? Any questions? All right, scrolling up. Okay, good. So let me once again erase some of this stuff. And I'll just erase all this. All right, so we have 2 plus 7x minus 5 equal to 6 times the quantity of x plus 3 plus 2x. First thing we want to do is to get rid of the parentheses. So we'll go ahead and distribute 6 to each term inside of the parentheses. So now we have 2 plus 7x minus 5 equal to 6x plus 18 plus 2x. All right. So now what we should do is, before we move anything across the equal sign, is to combine alike terms on each side of the equation. So in other words, I'm looking at my left side, let's simplify that as much as possible. Looking at my right side, let's simplify that as much as possible before I look at moving anything across the equal sign. So on my left side, I got a 2 and a negative 5 that I can bring together. So that'll be 7x minus 3. And then over here, I have I do have 2x, but I have 6x and 2x that I can add together. And that'll be 8x plus 18. Any problems? So now we're in the position that we want to get all of our terms with x to one side, all of our terms without x to the other. Once again, it doesn't matter which term you move first, which one you take to the right or left, just have to stay consistent and correct with your mathematics. So I'm going to subtract 8x from both sides, just because I want to emphasize something that's going to occur. So that's negative x minus 3 equal to 18. Then add 3 to both sides. These 3's cancel. And I'm looking at negative x equal to 21. So before we look to finish it off, any questions? All right, so we are not solving for negative x, we're solving for positive x. So I need to get rid of this negative, and the way we do that really is just to take it over to the other side of the equation, or apply it to the other side of the equation. Mathematically, what you're doing is either dividing by a negative on both sides or multiplying both sides by a negative. But ultimately, that means your answer would be x equal to negative 21. All right, questions? All right, let's do another one. All right, so here, our original equation, instead of erasing every single thing, but this is our original equation. And we have 9 minus the quantity of x minus 3 plus 4x equal to 4x minus 5 times the quantity of x plus 2 minus 6. So once again, we want to get rid of those parentheses first. So we'll distribute that negative. And a lot of people make this mistake right here. They forget to distribute the negative. So be careful. That negative needs to hit each term that's in that parentheses. Just like when we distribute this negative 5, it would have to hit each term that's in the parentheses. So that'd be 9 minus x plus 3 equal plus 4x equal to 4x minus 5x minus 10 minus 6. All right. So now, once again, what we want to do is simplify as much as we can over here. Simplify as much as we can over here before we move things across our equal sign. So combining my like terms, on this left side, I have 9 and 3, which would be 12. Let me erase some of this stuff down here. And then negative x and 4x. That'll give me a positive 3x. On the right side, I have 5x, negative 5x and 4x, then negative 10 and negative 6. So 4x minus 5x give you negative x, and negative 10 minus 6 gives you negative 16. All right, so once again, we have our variables in 2 different places. So we need to get all of those terms on the same side. Adding x to both sides. X is canceled on the right. Then I will subtract 12 from both sides to get the 12 to the right side. And that'll give us, got my marker here, 4x equal to negative 28. Divide both sides by 4. X is equal to negative 7. Okay. All right. Any questions? Any problems with that? All right. Let's see. I think this, yep. All right. Do 2 more and it will be good to go. So here we have 2 times x minus 4 equal to 2x minus 7. So when I distribute this 2, that's going to give me 2x minus 8. Now when I subtract 2x from both sides, notice that 2x is canceled on the left, but they also cancel on the right. So be careful with that, because a lot of times what people will do is they'll make a mistake and write negative 8 equal to x minus 7. But if it cancels out here, it has to cancel out here as well. So, I mean, if that happens, it happens. You can't be afraid to let math happen. Let math happen, not happens. And so what that leaves us with is negative 8 equal to negative 7, which is false. That's a false statement. So you look at blue, when the variables cancel and you end up with a false statement, your answer is actually no solution. Now notice your answer isn't false, neither is it false statement. Your answer is no solution. A false statement is what was the result of what occurred. All right. Questions. Make sure we're all right. So if ever your variables cancel and you end up with a false statement, notice I wasn't hooked up on the numbers, because you could have had 0 equal to 1 or negative 1 equal to 0 if you had did it differently. But the bottom line is that you would have had a false statement, because 0 is not equal to 1. Neither is negative 8 equal to negative 7. If your variables cancel and you end up with a false statement, your answer is no solution. All right, next problem, very similar. We have 4x minus 5 equal to 2 times the quantity of 2x minus 3 equal to 1, plus 1. Distribute that 2. That'll give you 2x, 4x minus 6 plus 1 on that right side. Combine your like terms. That's a negative 6 and a positive 1, which would be a negative 5. And so we will be left with this scenario. 4x minus 5 equal to 4x minus 5. So then you would subtract 4x from both sides. And once again, our variables cancel on both sides of our equation. This time we're left with a true statement. Negative 5 is equal to negative 5. Or depending on what you have done, you could have gotten 0 equal to 0. Bottom line, you would have had a true statement. Negative 5 is equal to negative 5, or 0 is equal to 0. So over here in the blue, lets us know what our answer would be. Whenever our variables cancel and we have a true statement, our answer will be all real numbers. So on the one previous to this, there's no value that you can plug in for x to make that a true statement. Remember, that's what our solutions are supposed to do. Plug it into the equation to create a true statement. So there was no values that can do that for the first one. And then for this second one, you can plug in anything and it'll work. All right, questions. All right. So as always, try the stuff out. See if you have questions. Always feel free to bring them to me next class or through email, and we'll go from there. You guys know what you got to do as far as the deadline is concerned. And if you have any questions, like I said, always feel free to shoot me that email. So you guys have a great day. Be safe. And I will see you on next class. Thank you. Goodbye. You have a good one as well.